And now I want to welcome Ellis with Instart Logic, who will talk about rigorous performance testing on the web. Please welcome Grant.
Thanks, everybody. Thank you, Sergey. My name is Grant Ellis. I've been in the web performance industry for almost 10 years. Right now, I work at Instart Logic as a senior performance architect. Before Instart Logic, I spent a couple years in the front-end optimization industry, actually working at Strangeloop, which is one of the sponsors, as well as Instart Logic, of course. I also spent more than 6 years at Akamai Technologies, which is one of the sponsors as well. So I've experienced triple sponsors, yes. So I've definitely seen performance on the web from a lot of different perspectives. So I want to encourage everybody to raise their hand, even in the middle of my talk. I want this to be interactive, and I want to answer all your questions, and I hope that we all learn something here. So the first thing I want to talk about is stress. Specifically, I want to talk about the things that stress out your typical performance architect. We all worry about our hosting and our infrastructure. We might have a really agile infrastructure in the cloud. We might have data centers, colos. We might even have a couple mainframes that we have to work with. We worry about our architecture. We might have a really simple stack with just Nginx or Node.js or Mongo or all of the above, or we might have an enterprise-grade stack with multiple sites, disaster recovery, replication, other things to worry about. We worry about our code. Whether or not we're using the most modern technology, we know that code has impact on our performance. We worry about browsers. We worry about how our code works with our browsers. We worry about all the different browser versions. And that one there is actually all the browser versions, courtesy of Wikipedia. And it looks like a mess because it is a mess. But we don't really worry about the internet, right? The page, it's generated by our infrastructure. It leaves our hosting facility. The internet just magically carries it all over the world to your eager viewers. They might be using any browser. It works really well, right? It's like a magic carpet ride over the internet. But you've probably heard other things. You've probably heard that the internet is actually a war zone. We all know this guy. There's all kinds of problems. There's overloaded switches. There are dropped packets. There's manually configured switches that are prone to breakage. There's under-provisioned transoceanic lines, and last-mile connections have too little bandwidth. There's first-mile pipes that don't scale very well. There's problems scaling your servers inside your data center. There's contentious network peering relationships, and lately they've been very public as well. There's all kinds of suboptimal routing within the ISPs themselves. Your traffic is a hot potato. They want to get rid of it for minimum cost. They're not maximizing your performance. But the truth really is somewhere in the middle. Servers are more reliable than they used to be. There's fewer moving parts. Software is more mature. There's a lot of best practices and documentation out there. There's lots of unofficial forums for modern and popular stacks. Scale on demand is a reality with cloud providers. Event-driven web servers like Nginx and app servers like Node scale like nothing in the traditional service space used to. Bandwidth isn't really a problem anymore, unless you're on a mobile connection. The first-mile pipes are thicker going into the data centers. It's easy to get multiple pipes. The cloud has also alleviated that problem. Last-mile pipes are faster and more reliable. And for those wondering, last-mile means home and office connections. There's cable, DSL, Google Fiber. Even LTE on your mobile phone is dramatically faster than the old technologies. There's huge amounts of fiber across the Atlantic and the Pacific basins. There's new fiber every day. But there are problems too, and these problems are real. Latency is a problem. Latency not only across the internet, but also in the last mile. There's packet loss that still happens due to congestion and due to increased mobile penetration. There are peering agreements between internet providers that still collapse very publicly. And there are still too many browsers. All of them perform differently. So I want to talk about the internet and the concept of the bottleneck. But before I do that, I have this slide here. I can't take credit for it. I wish I could. It's the most clever explanation I've ever seen for this. I actually sourced it from a guy named Raphael, who I regrettably don't know personally, but he has a great website which explains TCP. There's a lot of interesting terms there. If you're into network engineering, you should know all of them, and if you're not into network engineering, you should still learn all of them. But I'm going to talk about latency and bandwidth only for the scope of this conversation. In this analogy, the bandwidth is the width of the road. It's the number of cars that can pass simultaneously. The overall bandwidth in the network term is a function of the width of the road, but it's also a function of how fast those cars are moving. Fiber makes the cars move faster than copper. The latency is cleverly depicted as the number of kilometers to the destination. Well, that's very true in the network world as well. Latency is how long it takes for a car to get there, right? You may have one car, you may have 1,000 cars, but it still takes a fixed amount of time for the first car to get to the destination, and that's what latency is. The picture oversimplifies things, of course. In the picture, it looks like a straight shot to the destination, but we all know that there are rotaries and intersections and congestion points, places where the car is going to have to get off that main strip. Those congestion points may cause some of those cars to get delayed. It may cause some of those cars to get into traffic accidents. That's just like the internet. There are switches, there are congestion points. Sometimes those switches have too much traffic and there's a dropped packet, and that's just like a car accident. The analogy holds maybe far better than Raphael intended. So back to the history of the internet and the bottleneck, I'm going to start right at the beginning, and I'm just going to whip through these slides really quickly. We all know about ping. Ping has been used forever. What it does is it measures the latency between two nodes on the internet. It actually was introduced in 1983, and at that time, the internet was really simple. It was before the web even existed. Payloads were really small, bandwidth was really low, the internet itself was very small as well. Overall traffic was low. And so the biggest bandwidth was not the biggest bottleneck was not bandwidth, it was actually latency. So back around 1995, we saw the dawn of the World Wide Web. The picture on the right is Amazon.com's website in 2000, actually. But for anyone wondering, that's what it looked like in 1995. So here's the critical thing about the internet and the World Wide Web. The web made the internet viable for commerce and business. Websites became mission critical. Server-side functionality started to get introduced. Large companies and governments actually started paying attention to performance on the internet. There were a lot of things that hurt performance. Weak server hardware, clumsy scaling technologies, it was really hard to add servers, and there was really poor first-mile connectivity into the data centers. So the primary bottlenecks were absolutely hardware in the data center and the first mile itself. This is my bottleneck chart. You can see that in the bottleneck for the hardware, there were a couple companies that stepped up and said, we can solve that problem. F5 and NetScaler are two examples. They introduced hardware load balancers, which enabled any company with hardware scaling problems to add servers and scale themselves out horizontally as needed and easily with low risk. The bottleneck in the first mile was introduced by AT&T and other large telecoms. They said, okay, we can give you really big pipes now, much bigger than we used to give you. We can give you multiple pipes. And so the problems in the first mile were alleviated. At the time, people were worried about their hardware infrastructure and they were worried about their first mile. And so a lot of them were using a great software package called HP LoadRunner. HP LoadRunner repeatedly loaded whole pages from a single location over and over and over and over. And that was great for generating load and seeing how your servers held up. And depending on the location, it was also great for testing out your first mile connection. It was a stress testing tool and it was very good at what it did. It's really not the same as the game on the right. I'm sure a lot of you recognize it. So the internet started to modernize. That right there is Apple's website in 2005. You can see that it is a lot more immersive at this point. The scale problems inside the data center and the first mile connectivity problems were conquered. Adoption of the web increased some more. We saw Google, Facebook, fully baked e-commerce enter the web. And they drove widespread adoption of other sites as well. Governments started digitizing records and making web applications out of them. And international commerce on the web became common. So at this point, the bottleneck moved to the middle mile. Copper, switches, poorly maintained peering points. There's our bottleneck in the middle mile. A number of companies stood up and said, we can solve that problem. Akamai, Limelight, Edgecast, they said, we can move your data to the edges of the internet so you don't have to worry about the middle mile. They said we can use routing technologies so that we figure out where the congestion points are and avoid them. And they worked really well. They do a great job still on the middle mile. Testing tools popped up. Once there were solutions, everyone had to test performance on the middle mile. There's Gomez, there's Keynote. Both of them got a lot of business across the board. They were much better at the middle mile testing than HP LoadRunner, or what was then Mercury LoadRunner. They did a better job because they enabled quick and easy monitoring, and also they had their servers distributed around the internet. So you could actually measure from the middle mile, as opposed to measuring just the first mile or just your hardware. Just a quick warning for everyone out there. The testing agents for any synthetic testing agent are on the internet backbone. They're inside the data centers. What that means is that their servers are sitting on racks inside large telecoms for the most part. And what it means is that some of the CDNs out there have taken special care to place their nodes very close to the synthetic testing agents. So if you ever get data from Gomez or from Keynote, get the raw data too. Look at every single object. If you see response times for large objects around the 2 millisecond mark, you know it was made from fiber, across fiber from another server on the same rack. But they're still great tools. They're still great tools because they give you a great idea of what's going on all over the internet. But they are not representations of what your users are seeing. So there's still the last mile and the browser. And with the middle mile conquered and the first mile conquered and the hardware conquered, we worry about these last bottlenecks. And the bottlenecks have grown. We've seen very simple websites grow into highly immersive websites. We've seen adoption of new technologies like HTML5, which really encourage users to have great functions on their websites. We see a lot of images, and everything's very heavyweight. We've also seen other transitions. We've seen people move away from the humble PC to mobile devices, phones, tablets. Those devices, they're on mobile connections, which are limited in themselves, and they are also very underpowered compared to a desktop machine. Additionally, they brought with them recently high-resolution displays. All of a sudden, there are these really large images we have to transfer to have a perfect experience on a mobile phone. We don't really use Ethernet cables anymore in the home, in the office. We're all on Wi-Fi. Wi-Fi has a lot more latency than an Ethernet cable, and there's a lot more packet loss than an Ethernet cable, particularly when a lot of people are using it, and particularly in urban environments where the majority of the population is. 3G and LTE, of course, have very high packet loss and very high latency as well. So we know what this means. You use cutting-edge tech and immersive websites, access from mobile devices on a wireless connection. That means everybody's waiting. So it's okay because there are now some great last-mile tools that we can use for measuring performance. Before I do that, I want to talk about the latest vocabulary for performance testing. Fully loaded is one of the ones that you hear very, very frequently. And it really, really means that the page has been fully loaded. Everything on that page has been loaded. The connection has been disused. For a long time, fully loaded is what we had. That's what all the testing tools reported on. That's really just what we had. And at the time, the paradigm was very clear. Every website had to load everything or it wasn't working. But client-side technology has matured. And server-side technology has matured. Coding has matured. Browser mechanics are totally different now. What we worry about now is when the user can view the page. Fully loaded no longer has any correlation with readiness for your user. And now we have document complete to reflect that. Document complete is loosely when the page is actually ready for the user. It means that it's probably visually complete. It means the user can scroll or click links. It means that they can use the search bar. For the programmers in the room, it's roughly the same as the JavaScript onload event. So there are some caveats for document onload as well. It's possible to defer major page elements until after document onload. It's frequently done for below the fold, but it also can be done in other cases, even just at the top where it's very prominent, it's sometimes deferred. Keep this in mind, especially if you're implementing a front-end optimization solution. Many of the front-end optimization solutions make pages faster by ignoring JavaScript until after onload. And so what you get is a site that looks visually complete much faster, but is not responsive to the user when the document complete event fires. Document complete event is sometimes meaningless if you're using front-end optimization technologies. Not all of them, but some of them. So beware. Start render is a really important metric. It lives in the shadows of document complete, but I really don't know why. Everyone talks about document complete, but I think start render is actually more important. Start render is the moment that the browser puts something on the screen. And I mean something, I mean anything, right? It could be the whole page, it could be a single image, it could be a dot or a paragraph. It just means something is on the screen. So people ask me, why is that important? Why do I care? The reason you care is because the moments leading up to that start render, the user is staring at a blank browser window. And when they're staring at a blank browser window, they're thinking, is this page even working? Should I hit reload? Should I hit back? Should I go to a different site? Should I go back to Google? What do I do? Is this even working? It's like when you hit a button for the elevator and the elevator gives you no indication that it's coming. It's a big problem. And there's a lot of data out there suggesting that it's when abandonment happens most. That's when people leave your site, is before start render. So I think everybody should pay attention to start render, maybe more than document complete. So we have some great performance testing tools out there for last mile, but first I want to quickly recap some of the prior ones. Each of the tools does something useful. Ping measures latency, Load Runner measures scale inside the data center, and it's great for making sure you have enough servers. Keynote and Gomez are great for measuring performance on the middle mile. But none of these measure multiple devices. None of them measure multiple connection types. None of them represent the true user experience. So we need new tools. So we have a couple choices when it comes to synthetic testing. Web page test is an obvious one for a lot of people. Web page test is open source. That means it's fundamentally unbiased. It also supports multiple device types and multiple connection types. And for those wondering, web page test does reside on the backbone, just like some of the other synthetic testing agents. But in order to support multiple connection types, it uses simulated connections. It uses traffic shaping to introduce latency and limit bandwidth. But it's still a lot better than conventional backbone testing, where bandwidth is effectively infinite and latency is effectively zero. Web page test also offers great reports. Anyone who's used it really absolutely knows that. It captures waterfall diagrams, and I actually put one up on the prior slide where I was explaining all the metrics. Waterfall diagrams are very powerful diagnostic tools. But it has some limitations too. Web page test has limited analysis tools. It's really difficult to monitor performance on an ongoing basis. In order to do that, you need to use Web page test monitor, and you have to set it up on your own infrastructure, and it's really just a lot of top-loaded effort to do that. It also has some platform stability issues. If you run enough tests with web page test, you'll notice that sometimes whole nodes just go down. You'll notice that sometimes you will get a blank screenshot, or a page that used to have 100 objects in it suddenly has 2 or 3. It's just part of what happens because web page test has decentralized infrastructure and it's not centrally managed. So each node is sponsored by someone else and they are responsible for maintaining those nodes. So if you have that problem, just try a different node. Also in the synthetic testing space, we have Catchpoint and Keynote. They both support great ongoing performance monitoring, which is one of the big weaknesses in web page test. They both have support for start render and document complete. They both capture waterfall diagrams. On the con side, they are on the backbone. in every sense. They don't have any traffic shaping. They don't have any true mobile support. I have a lot of experience with all these tools. My personal preference actually is Catchpoint. I've used it at length. In addition to these pros, it actually has a couple others. It does have a mobile connection testing platform. So they actually have computers hooked up to cellular modems scattered around, so you can get true mobile load times. It's not mobile devices, which is why I said no true mobile support, but it is mobile connections, and it's a very, very useful feature. They also have a very powerful statistics package, which saves me lots and lots and lots of time. And then there's real user monitoring. There are a lot of players in this space. There's Pingdom, there's Sosta, there's New Relic. Gomez actually has a real user monitoring package, which is much better at getting true user experience than their backbone testing package, which wasn't on the first section because it doesn't support anything other than fully loaded at this time. Boomerang.js is also on that list. Boomerang.js is open source. It's a great package. It's much easier to use than a lot of other open source packages. I recommend it wholeheartedly. It doesn't include analytics. It's purely the reporting side of things. And so that's why you might pay for one of the commercial packages. So there are advantages to real user monitoring. They truly represent user experience. They're really easy to set up. You get great browser support across the board. There are multiple device types supported and multiple connection types supported. And of course, there's Boomerang, which is open source. There are problems too. They require live traffic. Okay? You can only use them on a site that already has live traffic. That means they are by nature responsive and not preemptive. You cannot test an environment before rollout. Also, the mere act of measuring your performance with RUM impacts the results. Measuring impacts. And the reason is because to make them work, you have to include them in the head of your file. And that makes the head bigger. It makes the number of objects bigger. And most importantly, the file you're including gets loaded near the top of the waterfall. And that's before the browser starts multitasking itself. And it's when it's most vulnerable to performance drops. Also, everyone should know that Safari is kind of a black hole in the RUM world. Safari does not support the nav timing APIs that RUM relies on. There are packages, including Boomerang, that take measurements from Safari, but they do so manually by starting and stopping timers. And they only get a subset of the metrics that they can get on other browsers.
There's a petition to try and change that.
I saw that. Let me know when you get Apple on the phone. OK, so there is one really big con, and I almost put this as the first one, but there it is right at the end. I want to spend a second talking about this. Outliers in RUM. RUM measures how long it took the page to load for every single user. There are users out there on incredibly underpowered machines. Think Windows XP, right? 16, very, very low spec, right? 2 gigs of RAM, 4 gigs of RAM, 3 or 4 antivirus packages installed. These computers are really out there, and they really are very slow, and they'll sometimes register 40 and 50-second load times. It really happens, okay? Think about mobile phones. I'm on my phone, I'm in the car, I'm loading your website. It starts loading, everything's great. My car goes into a tunnel. 2 or 3 minutes later, I open my phone, the screen comes on again, the page continues loading, and wow, my load time on my phone was like 5 or 6 minutes. Well, that all just gets registered as a 5 or 6 minute load time. Those outliers could really, really screw up your metrics on RUM, and you have to take care of them early. OK, so you've picked, go ahead.
So when you say outliers removed, does that imply that there's some kind of summary going on in the packages, or do you kind of preserve the observations?
That is a really great question. So for everyone else, the question was, does that imply that the packages are actually aggregating the results in some way? And the answer is yes. Almost every package aggregates the results as an average and reports only an average. And an average, we all like average, but it can be incredibly misleading because a single very long outlier can skew the data horribly. So yes, great question. And that's why we have to clean out our outliers. So you've picked your tool, you've picked your metric, you've ran your tests, and you have data. Maybe lots of data. Maybe you have 6,000 data points of data. That's a lot of page loads. This here is a scatter plot. I don't really know what's going on there. I really have no idea. I mean, maybe green is the fastest. It sure looks like it is. But maybe it's just that green is in the front. I don't really know. I don't know what to do with that. We need a better way to look at this data. Well, this is what a lot of the RUM packages do, if you're lucky, right? You might have average, right? And we know how much that can get skewed by outliers. You might have median, and median, you know, it's probably better than average, but the problem with median is that that's your middle of the road users. You don't really care about your middle of the road users. You probably really care about your slow users. Your slowest users, they're the ones that aren't buying. So why report on median? Maybe you get a standard deviation. That's actually pretty valuable, the standard deviation. That gives you an idea of how variable that data is. A lower standard deviation means that your load times are more consistent. Consistency is good. But if you have 6,000 data points, how can you express them with just 1 or 2 or 3 numbers? That's just a horrible oversimplification. There's a lot more going on there. Well, that's the other thing you frequently see in these packages. You see data plotted over time. That right there is the same data set plotted with an average at each time interval. It really looks a lot like red is probably the fastest there and purple is pretty definitively the slowest. But this is still a huge oversimplification. There's a lot going on there. I could equally plot these. They look completely different. On the left is the 100th percentile. On the right is the 95th percentile. They are wildly different. Clearly, there's a lot more going on here, and these charts don't capture everything. But really, there's more data. More data, okay? None of these capture the whole picture, none of them. And how could they? There are tons of different permutations here. There's different internet connection types, devices, browsers, geographies, wireless connection qualities, computing power, and there's probably 10 more that I forgot to put on the slide. And then there's the natural variability of the internet that just happens over time. So if you ignore all those things, there's another thing about plots over time. Aside from them being an oversimplification of the data, truthfully, they're not usually actionable either. I mean, if you find out that during peak internet usage time, your site slows down from 4 seconds to 6 seconds, what are you going to do about it? Really, there's not much you can. It just isn't actionable. So we can't take all those things and distill them into one number, or even one number plotted over time, so what do? This is a histogram. I'm sure we've all seen them. We've seen them for all kinds of things. But this is a histogram for performance. There are some packages out there that support them. This is one I made in Excel. All the charts you see here I've made in Excel. This is, again, the very same data, and this is just for blue. So let me explain what's going on here. The histogram breaks the traffic up into buckets and then expresses how many users experienced a particular load time. So a taller bar means more users experienced that particular load time for that bucket. Shorter bars mean fewer users experience that load time. Faster transactions are on the left side, and slower ones are on the right side. So when the taller bars are on the left side, it means that more users saw a fast experience. And when the taller users are on the right side, it means more users saw a really slow experience. If you're comparing two, you can plot them on the same histogram. Well, this makes it pretty clear that red really is faster than blue. There's no statistical cuts. There's no misleading data. This is everything. Everything's out on the table. We can see what's going on here. Look all the way to the left. There's a red bar there. There's no blue bar next to it. There are users there that saw significantly better performance than could ever be achieved by blue. The next bar next to it, look at that. The red bar is 2.5 times longer. If you look on the right side of the graph, the blue bars are all longer than the red ones, significantly longer. So what did we do there? We took all those slow users on the right side of the graph, pushed them to the left. Okay? Red is a much better experience than blue. Your slow users got faster, your medium users got faster, your fast users got faster. I have a question.
Well, the first bar could also indicate errors. Zero load time
They certainly can. This particular one doesn't have buckets. I kind of sanitized this. For the record, the bucket with the one red bar is actually a 1 second load time. You do have to normalize out errors if you're loading things into a spreadsheet. Yes, look for errors, look for response codes that are bad, normalize out outliers, especially if the data is collected from RUM. That is a very good point. Are there any other questions?
Can you comment on the very right bucket where there is more red than blue in the very right?
That means that there were more outliers for red in this particular case. So what that means is that there were more users in red who just saw a very, very slow load time. One thing about histograms is that they usually go sort of 1 to 2 seconds, 2 to 3 seconds, 3 to 4 seconds, all the way through. And then there's a bucket at the end, which is like n plus seconds. It might mean, that they have 10 seconds or 15 seconds or 20 seconds or 30 seconds. It doesn't really matter. They all go in that last bucket on the right side. In this case, maybe some of those outliers weren't removed correctly. So the histogram's really powerful. We all like histograms, right? I like it. It's great because everything is represented. It's great because it's easy to consume. It's great because nobody can misrepresent that data by cutting it statistically. It's all there, it's all on the table. But it has a shortcoming. There is finite granularity. It's only as precise as the size of the buckets. So I might have cut a histogram in 0 to 2 seconds, 2 to 4 seconds, 4 to 6 seconds, but with more granularity, say half second or quarter second, it might look totally different. So what if you need even more precision? You need something with more power. This here is a cumulative distribution function. If you have a statistics background, you're probably familiar with it. If you have a statistics background, you're probably used to seeing it rotated 90 degrees, actually. Well, what is it? It is, in fact, cumulative. What it really does is it expresses the percentage of page loads completed after a given amount of elapsed time. Okay? For the calculus folks out there, it's the integration of the area underneath the curve of a histogram. So for blue, on that particular data point, again, I removed the scale along the bottom, but that point means that 20% of the page loads for blue were completed in 5 seconds or less. Okay, that makes sense. Slightly less than 70% of them were done in 10 seconds or less. So just like with a histogram, a faster CDF is one where the curve is to the left and above the original one. Two data sets are equally easy to compare. Put them on the same graph. There it is. Well, the red line is higher and more to the left. So if you look at the gap between them, that's the differential. In this particular case, 80% of the blue users were done with their page. But at the exact same amount of elapsed time, 90% of their users were done with the page. That's really great insight right there. The red curve is above and to the left of the blue curve in all cases, every single case. There might be a few cases where it gets pretty close, but it's ahead of it in all cases.
So would the CDF be derivable from the histogram? And if so, isn't the histogram better because you have more information, you have a lost information like number of observations and things? So if you were choosing to kind of keep one versus the other and calculate the other, I can't imagine that you could calculate the histogram from the CDF, but you could calculate the CDF from the histogram.
Yes, I would agree with that. You can calculate one from the other. You can calculate the CDF from the histogram, but not the other way around. And actually, even that is not strictly true. In order to get a CDF, you would need to have an infinite granularity histogram, because what you're doing is taking the integral. So you can get pretty close to a CDF with a histogram.
The main point is that you lose a number of observations, which is sometimes a very important piece for comparing data.
Yes and no, but you gain other observations. I agree with you. I put them both here because neither one completely obsoletes the other. And I have to say, I love CDFs, but unless you explain them very carefully, they're not easy for certain people to consume. The histogram makes a lot more sense for most people.
You can easily go from the CDF to the histogram if you change from percentages to just your total observation. So 6,000 is your top. And
then each point there is going to be a discrete number that you're adding
Except
up.
for the total number of observations, which gets lost because you divide it.
Correct, because there's percentage. I mean,
If you get the top number to be your total,
Right, so as long as you keep the total,
yeah,
then you
it's
can kind of
honestly
derive
like
it.
6,000
Yeah.
or whatever.
As long as you kind of don't lose totals.
yes, that is a great point. The y-axis does not need to be percentages. It could be something else, absolutely.
But then it's harder to compare across two releases.
Right, your normal.
Exactly right. And for the record, we prepared this information for one of our customers. They were actually doing an A/B test for 2 different versions of their homepage. So this was actually a pretty good exercise for everyone. Did I see another question?
You were talking about the gap between the two being kind of a difference between the experiences, right?
Sure.
Can we quantify that and use that as some kind of measure of improvement in this particular case being a discrete test?
So Serge is asking if we can use that gap to sort of give a simple sort of one-liner explanation of how much faster it really is. I wish I could say yes. I mean, we can say, something like I had on this prior slide here, where 80% of blue was done after time X, but 90% of red was done after that same amount of time. But that one line is only for that one interval of time. The whole point of this visualization is it's hard to basically simplify it into a one-liner like that. I get that question a lot. What's the buzzword for my business owners? What's the buzzword, right? What's that one-liner I can tell the execs in the room? And they always give me that same problem that I raised earlier. The median has problems, the average has problems. If I take a 95th percentile, how do I know that A doesn't have more spikes than B? Maybe that just favors one over the other. Well, I could try 85th or 75th, but it just seems really arbitrary. How does the person I'm talking to know that this is really representative data? And there is no such metric, unfortunately. These graphs are the only way to get all that data represented. But there is one metric that's pretty close, okay? It's called the geometric mean, okay? A lot of people have heard what that is, but don't really know what it is. It's calculated basically by multiplying out all of the data points and then taking an nth root of how many data points there are. It's kind of complicated to calculate without a spreadsheet. But what matters is what it actually means and what it actually does. Very loosely, what it's doing is it's taking the data points that are clustered together and giving them more weight in the calculation than the data points that are outliers. Okay, so you're getting an average, but you're not getting the same skew with a geometric mean that you are with an average. It's very similar, but it counts the outliers while also giving them less weight than the ones that are clustered together. So a geometric mean is probably the best one-liner metric to use, in my opinion.
That's a complicated metric for a lot of people to understand.
It is, but it does give you that one-liner number.
There's another one that you can look at with the number of samples, which is the area under the curve, which is going to give you the total time that it took to load up your site. And if you do the difference, then you save that many seconds to all of your users.
Yes, you're absolutely right. You can do that. And in fact, there is a metric that web page test uses. I'll get there in a second. There is a metric that web page test uses. It's called their speed index. Do we have anybody in the audience that uses web page test often? Sergey uses it twice as often as everyone else.
Come to me for speed, you will use it too.
All right. Well, so if you run a web page test, it actually, one of the things it does is it plots visual completeness on a graph over time. So you end up with a curve showing how fast things get put on the screen. And the bar reaches the top of the screen when the page is visually 100% complete. It's great getting an idea of when the screen is 100% visually complete, but again, it can be very misleading if you're using front-end optimization packages that defer script execution, because visual completeness does not mean the page is actually loaded, because it might be non-responsive to the user till those scripts are executed. But the reason I mention that is because once it plots that stuff on the graph, it does in fact spit out a single number for its speed index. And it is in fact the area under the curve. So that's a very good point. Yeah?
tools that you mentioned give you the ability to graph the CDF, or is it just something that you manually do via spreadsheets? Or
There are some tools that will let you make histograms. I have never found one that lets you make a CDF. I made all of these charts manually in Excel. But you can use pretty much any spreadsheet package for them. I wish one of those packages would support the CDF. You know, I don't know if we have anybody here from Catchpoint, but you know, if you're listening, I like CDFs. So, any other questions before I just sort of tie it all together at the end? No? Okay. So, we learned a bunch of things here today. We learned that the internet is a jungle. There's a lot of things going on, there's a lot of problems, there's a lot of challenges, there's things that we can address and there's things that we can't address. But all the stuff that we can't address directly, there are ways to mitigate those things. Methodology matters. Arguably, it matters more than the results. One of the things about your testing methodology is that you can have really, really great data and make it look really bad. You can have really, really bad data and make it look really good. You can do that accidentally, you can do that deliberately, and this is especially the case with comparative data. Methodology absolutely matters more than the actual results. We learned that we have to pick our tool wisely. If you have a performance package that operates in the middle mile, well, consider middle mile or last mile testing, but don't test with a first mile package. Irrelevant metrics mislead, okay? If you're using front-end optimization with script deferral, don't look at visually complete. Okay, don't look at document complete. Figure out another metric. If you're using one of those packages that only supports fully loaded, well, keep in mind that depending on how your page is architected, it's probably ready for users far sooner than that. Performance is never a single number, except maybe the geometric mean. That's the closest I've seen, Sergey. If you express performance as a single number, it is by nature misleading, and is by nature it's not representative enough, okay? It's always a good idea to visualize it because you can always get something more actionable out of that. Powerful visualizations always trump aggregate figures. I know that's pretty much the same thing again, but it bears saying twice. Visualizations mean a lot. And spreadsheets are your friend. I didn't use any proprietary tools for any of these things. I did this all in a simple spreadsheet. So if you love spreadsheets, this will be easy. If you hate spreadsheets, but you work in the performance business, I recommend you learn about them. They're really not that hard, I promise. So that's really everything, but we do have time for questions. So are there any questions? There's a question.
So you talked a lot about, like, you know, performance testing. So like you have the load runner, which is, you know, you're sitting in your data center and you can simulate X number of users. But then you have like the ROM module, which is after the fact. Mm-hmm. If I'm designing a system, I need to know like how many users I can handle for this amount of time. How do you like put that together? Like, because, you know, you can certainly do a good simulation in the data center. So do you have to use some sort of extrapolation techniques with like some of the other tools? Like what's a good way to gauge like what my user performance is going to look like when I go live?
So that's a really great question. I'll just repeat it for everybody. The question was, if I have data that I measured in the first mile because I'm worried about the server provisioning, and I have more data that I measured with RUM, with the last mile, how do I sort of put the two together to get something actionable about it? I apologize, but you're going to hate my answer. I would keep them separate. When you're testing the first mile and you're testing inside the data center, what you're doing is you're exercising your servers and you're measuring performance at scale, okay? If you're measuring in the first mile, the reason you're doing it is because you're worried about how many servers you have provisioned, you're worried about your scaling mechanisms, you're worried about whether they're going to stand up or fall down at given traffic levels. And that's great. But when you measure with RUM, you're taking into account all those things, plus what's going on in the middle mile, plus what's going on in the last mile, plus what's going on in the browser. But here's the thing. If your servers are well provisioned, then middle mile, last mile, and browser latency are a much bigger driver for performance than what's going on in your servers, most likely. But if your servers are under-provisioned, then it really doesn't matter what optimizations you have in the middle mile and the last mile. It really doesn't matter. So I like to treat them as two separate mechanisms. There's performance at scale, which is all about making sure you have your servers provisioned appropriately. And then there's performance on the web. And for performance at scale, definitely use a great tool like LoadRunner. There's open source ones like JMeter. There's a lot of others out there. And for last mile, definitely think about RUM. Definitely think about some of the synthetic testers as well, but just know that most of them are on the backbone.
So how do I get the predictability for that for the last mile? Like, because with the load runner, as you said, you can do for performance and for scale. But before I go live with my website, how do I get some predictability what the performance would look like for the end user?
Another great answer. So the question is, how do I preemptively get a performance measurement for something that is not yet live? Okay. With real user monitoring tools, you cannot. It's very unfortunate. Real user monitoring tools measure performance of your actual users, and if there are not yet users, then there is not yet data, okay? The only way to do that is with synthetic tools like web page test, like Catchpoint, like Keynote, okay? Those testing tools, they all have a feature which allows you to override the DNS, okay? So that you can have an A/B type of test. In your A case, you have the baseline, which does a DNS lookup and loads everything in the baseline case. And then in the B case, you have something where there is no DNS lookup. It's just using a hard-coded IP that you specify. And that hard-coded IP could be a pre-production environment or a staging environment. And then it will load everything just like the A case, except with different infrastructure or a different site or whatever the one variable is. That's really the best way to do it. If you do that, just make sure that it's provisioned well enough that scale inside the data center is not a bottleneck. Wow, lots of questions.
You mentioned a couple of RUM packages. Could you, is there a preference, any package that would not affect performance? Mm-hmm. And secondly, would you typically just run it for a period of time to get some data, or would you keep it active?
Sure. So the question is, there were a lot of RUM packages on that slide. Is there any one of them that impacts performance less than the others? And the follow-up question was, do I ever see cases where customers turn on the RUM for a limited time and then turn it off again once they've got the data they need? Okay. So I'll answer them separately. I've worked with most, but not all, of the RUM packages that I've seen that I put on that slide. They all work in the same way. They use the browser navigation timing API, and they pull the data out of that, and then they beacon it back to the server where it's actually recorded, usually in the cloud. Okay? Boomerang.js works that way. Pingdom works that way. SOSTA works that way. In fact, SOSTA is actually based on Boomerang. Okay? They all impact performance the same way. If you're measuring Safari, it impacts performance more. And that's just the way it is, unfortunately. I wish I could give you a better answer on that. I'm not sure there's a creative solution. The amount that they impact performance really depends a lot on other factors as well, right? If you have very high server think time, then adding a tiny little bit more of critical path time to load that RUM module, it might be so trivial it doesn't matter. But if your server think time is really optimized, then those extra milliseconds where it's busy loading that one object and parsing the JavaScript and setting up the beacon might matter more. So to answer the second question is, yes, I've seen customers do all kinds of stuff. I've seen them turn it on for a day. I've seen them turn it on for a week or a month or a year. I've seen customers just say, hey, I want all this data all year round. I never, ever recommend that you leave it on for a day or a week or a month, ever. It's just not enough data, okay? There's all kinds of variations that happen, right? I mean, if we start talking about the traditional case, let's say e-commerce, right? Let's say we start talking about your business metrics, your conversion rate, your earnings per visitor, your bounce rates. You start thinking about those metrics. There are a zillion factors for that, just like there are for your performance, right? You can increase performance, and the expected result is that it will increase your conversion rate, and that's 99% of times the case. But there are other factors too, right? If your page looks unprofessional, people won't trust your site and they won't give you their credit card numbers. If you have an extra validation cert, they might trust your site more than if you did not have an extra validation cert. You might see different conversion rates based on how congested the internet is, based on whether you've just had a sale or will have a sale or are currently having a sale, based on whether your users think you're going to have a sale, based on whether your competitors are having a sale, based on whether it's the holidays or the summer. All these things matter, and all those things impact the congestion on the internet. And if you're using, say, a CDN, then all that traffic for your site and all your competitors' sites are all going through the same nodes. Just keep that in mind. I always recommend a month plus of data with RUM.
One of the things that we're doing for the RUM is, another option to use is percentage of the users that are actually coming in. So instead of measuring every user, you can do like 1%, 2% of the total traffic. So that kind of helps with the amount of data that you're collecting. So this is another option.
Yes, also a very good point. And a lot of the major analytics packages also sample in that same way.
So what the packet we're using is actually from Gomez CompuWare. It's called real user monitoring. It puts a JavaScript in. You can actually see exactly what's going on with the user's desktop, what browser they're using. It's very good metrics for that.
Yeah, I've heard great things about the Gomez RUM package. So I'm glad you've also had good experience with it. Gomez did a really, really good job of selling its synthetic package. It was one of the first companies to market with that. And they did such a good job selling that tool that they're really having a hard time selling their RUM tool because all of their existing customers say, hey, we've been using your synthetic tool for 10 years and we've been sending weekly reports to our execs from your synthetic tool for 10 years and now you're telling me that there is actually something better? So, but yes, times change. RUM does measure last mile and middle mile measurements are really not the same.
Well, I just have like two quick comments. The first one was we were talking about all these graphs and spreadsheets. So, I used to do that for a while too, but then eventually I got tired of doing the reports together, so then, I automated it. So as engineers, we think about automating it. I was kind of surprised you bring that up. We've been doing this for so long time. And the second thing was you should think about your APM solutions because they also do impact performance. So for example, we're using New Relic for back an APM solution and it's, it does impact performance. Like it does inject, it's like whatever it's doing, like it is affecting performance.
Yep.
You should be aware of that as well. So even though the data is good, you got to be aware that it's gonna cost you somewhere. It's nothing.
Exactly right. So what he said was that the RUM packages out there, including New Relic, which you have personal experience with, it sounds like, absolutely impacts performance. The mere act of using RUM slows down your performance.
Talking about the back end.
Oh, well.
Back end APM solution where New Relic monitors your back end servers and services and how what's happening in your PHP, what's going on in the back end. Not their RUM. Their RUM is fairly new and unproven so far, but I'm just talking about just their back end solution.
Yes, another good point. New Relic is unique in the RUM space, well, fairly unique in the RUM space, that they actually have full stack diagnostics. You can put agents on every little item within your stack, and for every request, you can basically trace what took what amount of time. So you can say my database took this long, and my web server took this long, and my app server took this long, and web latency with this long, and this happened in the browser, and here are the browser metrics. And it's quite powerful, but every time you put an agent in there, there's overhead, right? And all of them can impact performance end to end. So that's a very good point. And the other point that he raised is that it's possible to automate a lot of the things that I do manually in a spreadsheet. And I have explored that and I have done that. My use case is probably very different than yours. I work at a performance company, which means that I'm performance testing hundreds, thousands of sites, hundreds, thousands of pages, not hundreds of thousands, but hundreds or thousands. I'm doing this all day, every day, and every time I do it, there's different variables, there's different geographies, there's different key browsers, and there's different tools, and the customer wants to use different tools, and quite honestly, it's hard to automate it that way. But if I was a performance architect at a particular website or a particular service, yeah, I would automate it, and that's a really great point. And I definitely have experimented by using some of the big data platforms for that, building dashboards out of it. There's a lot of great packages out there from companies like Good Data. So I definitely recommend you explore that if you intend to measure performance on a regular basis using synthetic technology.
So that was a great talk. It's actually made me curious about Instart Logic. Could you just remind me what performance solutions you have or do at Instart Logic? And then do you guys have like a tech blog? Will you kind of talk about this a little bit in a while?
Sure. Well, I'm not supposed to talk in great technical detail about Instart Logic this time, but I can give you a pretty helpful overview, I think. So firstly, we do have a blog and we do have a website, and you can find everything at instartlogic.com. We have designed our product to be basically a drop-in replacement for a CDN, a conventional CDN. Basically, what we've done is we've built an enterprise-grade CDN that has all the good stuff that the other CDNs have, including caching, routing optimizations, transport-level optimizations, all that good stuff. Bolted on top of that, we've basically designed what we call our streaming technology. And what we've tried to do is we've tried to stream a website in the same manner that we stream video today. A little extra context is probably necessary for you to understand that statement fully. If you think about what happens when you load a web page, you request the base page, and then you get the base page after waiting a certain amount of time based on network latency and server latency. And then once you have the base page, the browser parses it. It executes inline JavaScript. It parses and interprets inline style sheets. It figures out what else it has to download, and then it starts fetching those. And then it starts fetching some more, and then it starts fetching some more. And there is a cascade of requests that the browser has to make. And for each request it makes, the browser has to do something. It has to interpret the image and put it on the screen. It has to interpret and parse the style sheet and possibly repaint the screen multiple times. It has to execute the JavaScript and possibly put together data models, or possibly work with local storage, or possibly interact with the document object model. So in short, there's a lot of things the browser has to do. And what that means is that the browser is not loading things in an optimal fashion. There are large parts of time where the pipe is not getting used because the browser's just waiting, or it's executing JavaScript. And that's time where it could be using the pipe more optimally. But more importantly, the browser does things in the order that it encounters them. So if you have a JavaScript and a style sheet and an image, well, it's going to load them in that order. And that order might be really, really suboptimal, right? Because maybe some of them are higher priority. So what we try to do when we stream a website is we chunk up the website into smaller parts than perhaps are already there, right? So right now your website has style sheets, images, and JavaScripts. Well, we split your HTML into multiple chunks, and we split your images into multiple chunks. And with that, we have granularity for decision making. And we can make decisions based on the priority. And that means that we can make that waterfall more efficient, and we can make the way that the pipe is used more efficient. And we do that without changing a single line of code. So we're able to do it in a very reliable fashion. So that's kind of the short story. There's a lot more material on the website. Sure.
Okay.
All right.
Thank you.
Thank you.